Christina, do you start?
Yes, I think we have a few more people who might join, but let's start, and they are welcome to join whenever. So welcome to this session in the flipped IRSPBL 2021 series. I am Kristina Edström from the Royal Institute in Stockholm, Sweden, and I have the honor to host this webinar. We will have 3 presentations. You can switch slide, Christina. Yeah, we will have 3 presentations. So just a short introduction now, and then 3 authors will present the contributions with 3 to 4 minutes each. And we will get back to plenary discussion, and I hope we will have almost half an hour for that. So let me just explain the structure. Each presenter has 3 or 4 minutes, and then we will have the plenary discussion, but you are very welcome to write comments or questions in the chat all the time. So please turn on the chat window and start writing as you please. In the discussion, we will of course address the topics of the papers, but we can also move beyond those papers and discuss sustainability, complexity, interdisciplinarity more in general, with input from both authors and participants. But please make notes and write the comments and questions to the authors while you are listening to their presentations. If you back up 1 slide, Stina. If you go back.
Yes.
Yes. So the issues that we will address in this webinar session are things like what complex problem-solving qualities are essential for coping with future sustainability challenges. How can students' understanding of sustainability evolve through their study time? And generally, how can complex problems be addressed in engineering education? So we have some more specific topics of those papers, but they really group together very well in this theme. So let me introduce the first presenter. It's Dr. Jeannie Servant-Miklos from Erasmus University, Rotterdam. And we will see her slides.
Yes, I am working on it. If my computer wants to work with me.
I will start coughing if you go over time. It doesn't mean I have corona, it's just a signal to the presenter.
So.
I'd just like to point out that we opted to make a video because we weren't sure whether I was going to be able to talk today or not, since I'm recovering from an operation. But the video is so beautiful that we decided that we're going to show you the video anyway.
In this short presentation, Jeannie, Annette and I would like to share with you the results of one of our recent studies documented in our paper, A PBL Effect, a longitudinal qualitative study of sustainability awareness and interest in PBL engineering students. The study was initiated due to our curiosity about the ways students develop their awareness and interest in sustainability issues during their education. We studied this process in the systemic PBL environment at Aalborg University, and we focused on the first 3 semesters where students are adjusting to the PBL environment. We furthermore studied differences across different engineering programs to capture potential impacts from disciplinary settings. We chose a qualitative and longitudinal approach, including a thematic analysis of 16 participants from engineering and science programs, including more classical engineering programs as electronics and mechanical engineering, the more hybrid program Mediology, which combines interaction design, media technology, and programming, and finally, the environmental management program to include a program having a more direct link to sustainability science. Ginny interviewed each of the participants 3 times of a period of 18 months. Overall, we found 4 different categories of interest and awareness during this study. Category 1, where there is no interest and limited awareness. Category 2, where there is limited interest and a basic awareness. Category 3, showing a basic interest, a basic systemic awareness, and also a high disciplinary awareness. Category 4 includes students being highly interested in sustainability issues and having a high systemic awareness in their studies and as a part of their lives. If we look at the development of students' interest and awareness, we see that for students starting in Category 1, most students developed to a higher level and half of the students came to link sustainability to their future engineering profession. However, we also have one person which hardly moves from the outset of no interest and limited awareness, which reminds us that education for sustainable development needs student engagement. For all 5 students starting at Category 2 with limited interest and a basic awareness about sustainability, we saw a development to a higher level and even one move to a more systemic level. For the 3 students starting at level 3, 2 of them developed to the systemic Category 4, while one more or less corroborated his Category 3 position. This, however, was more due to the lack of energy to move further than lack of engagement in sustainability issues. For the 2 persons starting at level 4, we found that one person actually went backwards. This case raises concern about whether education for sustainability can be too disciplinary in scope. Finally, we would like to discuss with you the potentials of creating synergy between the PBL effect and the Greta effect we have seen in this study. We should capture this moment in time to provide new learning opportunities for students being engaged in sustainable development. In this concern, problem-based mega projects could be a way to go. Thank you for your attention.
Lovely, thank you so much. I'm sure we all have questions, but let's do the 3 papers in a row and save our questions for later. We can still ask questions to the specific papers. So the second presentation is by Dr. Leilani Smith from University of Pretoria.
Yes, if I can find it, I'm sorry. This will not work with me. Sorry, Leilani, here it is.
Thank you. Thank you. So yeah, I'll present quickly a framework and a structure that we've developed at the University of Pretoria, and just discuss some current student and staff experience of an interdisciplinary multinational co-curricular aerospace design project. So Stina, you can change to the next slide. Just to give some background of the university, we have extremely large cohorts, 500 plus students in most modules. It's a 4-year degree, and the curriculum framework currently is based on CDIO principles. And the idea would be that there's a PBL facilitation within the classroom, but that becomes really difficult with the large cohorts. The degrees are EXA accredited, so Engineering Council of South Africa, and that is according to the Washington Accord as well. But the curriculum is also very inflexible, so there's no electives or anything that we could use to try and introduce active learning in different modules. So we start to come up with creative ways and innovative strategies to still allow for this kind of student engagement where there's active learning, there's a creative input, where we could really play with ill-defined projects and give them a bit of an experiential learning feeling, even though we have these large cohorts. And so we started looking at co-curricular opportunities within our main curriculum. Next slide, Stina. So just to give you an idea, one of the projects that exists at the moment is called the RN project. So it's contextually, it's based in rhino poaching prevention. And so in terms of rhino poaching prevention, we're defining a very, very vague problem. So giving it that feeling of the ill-defined problem for the students to work in. And we then give the students a learning pathway from their second year all the way through a postgraduate structure. So we have in the center here, you'll see at the top, there's a team leader. So for example, there's a staff member that takes on the role of what is the problem about. And you could have other staff members depending on discipline-specific problems that we have. So other staff members might be involved. So in the second level, you could have, for example, we have electronic engineering involved. We have postgraduate students that act locally and internationally from international universities as project leaders. And they often also have projects that have specific design outcomes. So all of these modules that we've included here, the fourth year modules, the thirds and the second year, are all existing project-based learning modules within a larger curricular structure. And typically each of these problem-based modules would have a staff member responsible for them. So each staff member has about 15 to 20 students that they are responsible for. So in this system, I would basically give a main project and make sure that the subtasks are allocated to each of these students in the project, specifically designed for their level of outcomes. So a second year would not have the same complexity of a problem as a third year and the fourth year, for example. We also interface with international universities. So on the left, those were some universities we've worked with. And on the right, we have a lot of mentorship and engagement with industry, where the students can even go and learn small parts of a greater design in industry, and then they come back to the main team to produce some subsystem or some integration phase for the specific design that we develop. So this is just an overall framework. So Stina, you can move on to the next one. So there were a lot of challenges and opportunities within this, and I'm not going to go through all of these, but I think some of the main ones that we're currently looking at is the way that the students self-directed and self-organized. It's very little staff input with a large group of students. So we have about 30 students in each of these kind of vertically integrated projects. We scaffold their learning specifically through a centralized project where they can come in and really understand how their different technical fields kind of coincide in this central project. There's a lot of opportunity for students to fail within their individual projects. Because the overall project, there's still potential for failure. Individual projects can still pass the module outcomes, even though the overall project is not successful per semester. So that kind of gives them a nice opportunity to engage with the work as well. There's a lot of opportunity for them to become really frustrated with the way it's facilitated. So they really start engaging in a very strange space where they're not used to in their normal curriculum, where there's no active learning opportunities. This is really the space that we've created for them to try and develop that autonomy and innovative aspects of the work. Last slide, Stina, thank you. So the future plans, we're taking this 6-year program that we've currently run, and we're trying to look at what we've actually accomplished. So we're in the process of interviewing students, some alumni. So we have 4 years of students that have already been working, and also looking at current students in the project and on the teams to see what we've actually been able to facilitate in a small group like this in order to make it a larger program across the whole faculty. So currently we're looking at that as our next step. Thank you.
Thank you very much. That was an exciting world to be invited into. So our third presentation about project types and problem-solving competencies is by Professor Annette Kolmos.
Yes, and how to follow up on these two presentations. Let me see. Yes, it's we have for a long time at Aalborg University, we have discussed that we actually have different types of products. And it's important to start conceptualizing these different types of products, and also how we actually are moving from a very disciplinary products. Sometimes our students are doing very disciplinary products, and I also see a lot of disciplinary products around the world, but also towards something that is much more complex, and how we can deal with complexity in the product approaches. So it's me, it's Lykke Bertels is here as well, and it's Jette Holgaard, and it's Henrik Worm, who is the authors of this. So the framework that we have developed, it's actually that we have two dimensions. We have teams and network, and we have the interdisciplinarity. And where we have less of both, we find the traditional discipline project, which we see very many places. But we also can see that sometimes we have disciplinary projects where actually several project groups are working together. So this is what we call the multi-product, and we see it especially within software area. Where we have more of interdisciplinarity, we see that we have the interdisciplinary project with maybe only within one team, but working with a problem from different angles. And then we have in the right corner, we have the narrow and the broad interdisciplinary mega projects. And the mega projects is something new that Aalborg University is trying out. I wouldn't say that we are experts, and I am looking forward to learn much more from Lilani, because I think this is also a kind of mega project that they are doing. The theory behind it is that we have variation in learning, and many of our students are actually reflecting on the project process. So, and to reflect on project process, it's important that it's not the same every time. So you have a sameness in order to transfer from one area to another, but you also have a difference in order to learn. So it's very important that the projects, they have differences from one semester to the other semester, or from one course to the other course. But when they have differences, students should also be allowed to, or be facilitated in the reflection. The differences, we very often we see that in the way we define the problems as something that can be student-driven, teacher-driven, or it can be open problems or ill-structured. It can be narrow problems or well-structured. So this is one of the very normal variations that we have in PBL. But what we also try to do here is actually then to say we also have a variation in the products, of course, because the products follow the problems. This is, I think, most of the product types that we are describing. These product types are more or less well known. But what is not so known, this is the mega product. And I will not go very much into this. I have colleagues in this session who can tell much more about it. But we have a focus, and it's can be on simplifying sustainable living. It will be offered to all programs in all 5 faculties at Aalborg University. And you will have student groups coming in from their discipline and coming in then working on, for example, one of the challenges can be waste. And they can be working on then how we are handling waste in private household. So it can they can both come in from biotechnology, sustainable design, sociology, architecture and design, or whatever program they come in. And they work on this challenge in this cluster from different discipline areas. And throughout the process, they also communicate with each other and exchange their knowledge, their ideas. But we are in a process right now of developing the mega projects, And we want to take this a step further. So they're also working on more common innovations, more common products. The last is that one reason why we think this is so important is that you also gain some competences, some process competences, PBL competences, reflecting the different project processes. And if you look at the very narrow disciplinary approach, you might understand the problem in the discipline domain. You have a very stable structure, and the collaboration, it is a collaboration actually within the same knowledge paradigm. But if you look at the more narrow interdisciplinary or the broader interdisciplinary, you will see that you have an understanding of the problem from more different angles, and you will need to have a much more agile, flexible structure for the project management. And you will have difficulties in your collaboration because you come in with different conceptual frameworks, and this is a challenge. The reason why we want to move a little bit to the right or more to the right, or letting the students have an experience from maybe all the columns here, it is that if you go to companies, there's no doubt that complexity is something that is dominating a lot of the engineering work today, and that the ability to work interdisciplinary, it's really something that companies, they ask for today, as well as they of course ask for the disciplinary competences. Okay, thank you. I'll stop sharing.
Thank you very much, Annette. And let's give all three presenters an applause, although a little bit silent, I think. Wonderful. So let's see if we have some questions in the chat. Nobody has written yet. Oh, I love those applause icons. We have to trust everyone to be there. So who wants to start? Did I see actually a hand going up? Maybe someone was just scratching themselves.
I would like to start.
Yeah.
If I'm allowed to.
Please.
Because I think you're right that these three papers actually fit very well together. And Lilani, what you are doing and the problems that your students are working on, are these sustainability problems? How ill-structured are these problems? And how do you use the elder students to facilitate actually the younger students? And what is then also the role of the teacher? Because it seems that the teacher is the project leader for the whole project. And so when I saw your scheme, I had so many questions.
Yeah, thank you, Annette. That is many questions. I don't know if I'll remember all of them to answer. So I think, I mean, initially when we started thinking about the problem, it wasn't necessarily a sustainability problem. It was more a crisis. There was like this, in 2014, there was a massive influx of rhino poaching happening in South Africa. And so we were just trying to address an immediate need. Only later that we started thinking about, should we maybe align these kind of projects to a sustainable goal, development goal, specifically in South African context. So we're currently, the newer project that we have are more following that kind of trajectory. But this problem was basically trying to fit to a technological solution. So, and it was also a learning curve because none of us have any real training in PBL, which is quite unfortunate, but it was almost a learning curve for us to see what the problem requires and how we're going to fit or give students access to it. So maybe to answer that part of the problem. So this is my team. I'm the team leader for this specific project, and I'm very hands off with them. So I give them a vague instruction like, we need to figure out if we can provide a technological solution that includes a drone for the Kruger National Park to help the rangers. And then they have to go out and speak to the people in the parks, people that have done something with drones, the rangers, what is the requirement, what is the movement of the rhinos, what is the movement of the poachers. So they have to do that kind of research and then come back with some proposal of a strategy, like, okay, this is the mission plan. And from there on, only do we get to the engineering design parts, which is very much the students. I almost treat the students like I'm a client, and I ask them and they come back and they pitch something to me. Every 2 months or so, we have one engagement and I tell them, no, I don't want this. I want it to click on, click off. Like, I give them very vague instructions. Vague enough to frustrate them, but clear enough so they know at least in what direction to kind of take their research. And I usually work mostly with the senior students, so the final year students, and I kind of coach them through a process of how they have to manage the substructures. So none of them have any formal training of how they do this. And I think part of the interview process we want to do is to try and figure out how they self-organize, because that's really much an organic process. We don't define or give them clear direction in terms of how to self-organize. And it's not always the case that the older students mentor the younger students. It's sometimes the other way around. So because it's so badly defined and badly directed, and I mean on purpose badly directed, I stand off quite a lot. Students kind of get frustrated and they step in and they start making decisions. Once they start making decisions, I stand there to just say, okay, think about this, think about that, think about this. So in that way, they kind of have some organic process. And I think that's part of the research that we want to try and excavate, like how do they even self-organize? How do they communicate across year groups, across these different parts? The only thing that I really give a lot of work into is when I have a new student entering into the team, for example, and say they're coming from a second year electronic perspective, I would give them a short brief. Okay, your job is to look at this part of this subsystem. This is your work. These are the students that have worked on this before. This is how it fits into. These are the students in the bigger picture. Find your way. And that's as much as I do. So there's a lot that we don't know about how they do it, which is why we're looking at like disseminating a bit, like what happens, like how do they actually do this? I think most of the engagement with them, I also work on a personal level. So it's the technical stuff they figure out, but they don't really know how to work with their personal frustrations or feeling incompetent or struggling with team members that don't bring their part or that doesn't show up in the correct way. And so I usually just kind of talk them through how to communicate in that process. But I don't know if that answers all the questions, but maybe some of them at least.
I think it's really interesting. You mentioned during your presentation, Leilani, how the students are not prepared for working in PBL projects, but also how faculty are not prepared. And it's a bit about how to handle those, how to live with those frustrations and those ill-defined, the ambiguous aspects. And that's I think it's a very exciting side of these, of moving into these formats.
I completely agree, Christina. I maybe want to just comment on that. I think that's been, because I'm in mechanical aeronautical, even in a design, like teaching design capstone projects, that's been a contentious point about, should we just give them enough specifications so they jump directly into design process? Or should we let them start from the problem definition? Because that's actually the part that very few of us, at least in the University of Pretoria context, we're not trained to facilitate a process. We can do the theoretical part. This is how you do problem definition. This is how you do client requirement breakdowns. This is how you do. So there's all kinds of theoretical frameworks to do in that, but the students don't necessarily have any facilitation through a process of frustration. And I think the beauty of PBL is that engagement from the student side, but the facilitator of that, you need a specific person to facilitate that. And I think through trial and error, I kind of learned through this team, and I think the students also learned through this. And I think 3 years ago in 2017, I had to sit down with an educational psychologist that looked at the project from an educational perspective, and that changed my whole career trajectory, actually, like moving into a more engineering education direction since then, because I became fascinated with how this can work as a facilitator of this process. So I think you're right. I think to train staff to facilitate an effective PBL is quite an art. I don't quite know how you guys do it, but we're definitely not trained to do that. So we're trying.
Anybody who has some secrets to share in that respect? How do you handle your own anxiety when the students get anxious?
Me personally, I do a lot of yoga, meditation.
I mean, it's a trade-off. We want to make the learning experiences authentic, in as complex as the real world almost. But we also want to shield the students and being able to focus on how will this little part come to work with the other part, and that's complex enough for a beginning learner.
Yeah,
I think that facilitation is some kind of an art, actually, because to my experience, you never know when you facilitate a group of students what is actually going on in the group. You never know, because you cannot unzip one person, but you can definitely not unzip 6 person in a group. So it is an art to figure out what is going on in the team, and how can we actually then progress, and what motivates the students. That is very, very complicated, I think. And I think we do a lot at the tacit level, that we don't know what we're doing, but we are doing, because we have some experiences, and when we see some habits, we just go in another direction. So it's actually quite difficult to do it also explicitly, I would say.
Jeannie, sorry, I was going to ask Jeannie, from your interview series, did you get any insights into how students were living in this context and in relation to the theme that you were exploring?
What do you mean by living?
How the lived experience of the curriculum, and how that could have affected their development?
And this paper was part of a series of papers. So we have a much broader data set than we just presented right now. And one of the very interesting components that we didn't discuss in this short presentation, but that I do discuss in several follow-up journal articles, is the role of campus culture and specific faculty culture that is also mediated by faculty and staff in developing engineering identity, and the interaction that has with sustainability, interest, awareness, and engagement. And for instance, what we saw is that in terms of engagement, the majority of the students prefer to engage on, let's say, a professional level, in the sense that they see their engagement as geared towards engineering careers and very technology focused and oriented. Perhaps not entirely surprising in an engineering faculty. But through a brilliant literature review that Jette did, we found that there are some other prominent modes of engagement, like individual level engagement, changing to sustainable lifestyles, institutional engagement, where students get involved in including sustainability issues on the curriculum and other institutional level happenings, and political engagement, where students engage outside of the university and then bring their experiences from activism back into the university. There were some students, particularly in an environmental planning program, that also due to, let's say, selection bias, namely they had an interest in sustainability before registering for their program, They engaged politically with Extinction Rebellion and the Green Student Movement in Denmark. But what was very interesting is we saw a very hostile reaction to this on part of other people in that program, who were telling them things like, these are not real engineers. So there was a feeling that political engagement was incompatible, and even there was one or two students who were using quite harsh emotional language, saying things like, you know, they are almost dishonoring the profession of engineering by taking part in mass protests, or that they were called propagandists by their fellow students, which was causing a huge amount of tension within the PBL groups, to the point that one chap I interviewed even quit the program and went to a different study because of these tensions. So, and I don't think that the supervisors or staff are necessarily aware of the central role that they play in defining campus cultures, which research has shown has such an influence on the kinds of engineering identities that get developed, and then that impacts how the discourse around sustainability evolves within the engineering faculty.
Wow, what an example. Graham, would you like to pose your question? I'll turn on your mic for you.
Hi.
Okay, good.
Hello. Yeah, I found the talks very interesting. I really like the model showing the students' interest, how it progresses in sustainability. We've done some research at UCL within the computer software engineering, and we found certain trends. So for instance, we found that female students particularly are more interested than male students in sustainability. For male students, we find that they want to develop an application from end to end. So we've done some research on this to try and develop PBL projects that actually fulfill every gender's needs, and also different cultures and also different abilities. I use the term abilities in the term of BCS, in that we don't tend to use the term disability, we say abilities. And the students often say if a student is colourblind, they say that student has a special ability to be able to identify a more useful piece of software that can be viewed by a wider range of people.
Jeannie, did you see a gender difference in your data?
Certainly a gender difference in sustainability. There was a high interest in health and sustainability for female students.
You were asking me, Christina?
Yes, in your diagram with where they were moving, did you see a gender pattern?
Well, we already see in the selection bias that whereas all of the other engineering programs that I surveyed were heavily male dominated, the environmental management science, or BEM, Bachelor in Environmental Management program, was heavily female dominated. But within the data itself, so the two that were politically engaged were both women. But there was also some heavy vitriol from other female students who wanted to identify more closely with, let's say, the more traditional or classical version of the engineer. I do sense that there were gender dynamics underlying that as well, in the sense that some of the women who rejected political engagement were thinking, I've worked this hard to integrate as an engineer, and I feel offended that these other women are, let's say, validating the prejudices that men have against women in engineering, that they are not serious about engineering because they're doing all this political activism.
We have a question in the chat from Roberto Herman. Would you like to pose your question?
Hi, yes, a question to Annette. When you implement the mega projects and then you propose these multidisciplinary projects, However, if you go to the bottom of the diagram, like there are some thematic areas like e-waste and so on. And it seems like some of the groups come from different semesters, right? So my question was more like who owns the problem? Will it be more teacher-driven problem, or in a sort that these groups act like consultants, or they still have students driven problem in this kind of setup?
I would ask Løkke to answer that question. I think she's much more knowledgeable in that.
Okay, I'll try my best. So there is in each of the challenges in the mega project, there is a sort of a challenge owner or challenge facilitator who will help sort of facilitate the collaboration in the clusters. And in some ways, that person is in some cases assigned sort of the ownership. It isn't necessarily so that it's actually the case, but we have seen in some instances where the facilitator is quite active, that the students then maybe take a little bit less ownership over the projects. So there's a balance there in having a facilitator. Of course, we know that it's needed. We can see that from the spring and the fall last year, and also in the beginning of this fall, where we have the new mega project starting, that the facilitator is very important. But it's also important that it's a person who is able to step back and let the students take that ownership of the project.
I think we have an interesting discussion going on in the chat about what students come motivated for. So do they come expecting to work in teams on these projects with lots of uncertainty and ambiguity? Do they come because they want to work on saving the world and sustainability issues and we have a Greta effect? Or do we have all the nuances of students where some just are interested in little electronics components and don't bother me with the socio-technical aspects on those? How do we handle that?
I saw something quite interesting talking about these students who just want to work on their little technological gadgets. You saw there was a young chap who did not evolve at all in terms of his engagement, and I asked him about that in the last interview, and he said something very interesting. He was like, there were two of them actually who were more or less in that position, and they said, so in the beginning, and when I interviewed them first, they didn't know, didn't care. By the end, they knew. But one of them said, I can feel the mask peeling off and there's cracks appearing and I just want to cover my face and cover my eyes and not look, because all I want to do is make video games, and I'm afraid that if I start getting involved in sustainability, I'm going to feel compelled to just go down that road and it will distract me from being who I want to be, which is a game developer. So we see identity issues appearing again and again and again in kind of the motivations that students have for engaging in this or that topic. So I think one real avenue forward is to make it not an either or. You can be a game developer and still get involved in sustainability issues. And I think that's also where showing the kind of different spheres of engagement that Yeda identified is very important. There is not just one way that you can get engaged in that sense.
If I can follow up on that, because I think that motivation, we see there is an increasing motivation based on sustainability, and that the students say, I don't know if it's a greater effect or if it's a broader effect, I don't know, but never mind, but we see that. But what we also see is that we still have the more nerdy motivation, the tinkering, where you want to sit and do things. So it's this with the tinkering concerning actually versus the more social, the broader aspect. And I think that also for the mega projects and how actually to motivate the different programs to get into the mega projects. I think sometimes you go from the very concrete and then you go more and more abstract. And sometimes you go from the very abstract and the very big climate crisis, and then you have to somehow reduce that to something that you can work on in your discipline. So I think that we just need to acknowledge that we can go both ways, and the motivation for students also, sometimes they are very nerdy, they're very focused on being in the lab and doing something where you can get a fact, but slowly they might evolve in their approach to sustainability, and vice versa.
Yeah, I think maybe I can also say something. I think Annette and Jeannie are raising really excellent points. And I think that holding both parts and being able to move in both directions is really important. I think for us, what sometimes motivates the students with us is also because of the large cohorts. It's nicer to work in a closer proximity to a lecturer. In these kind of groups, you're in 30 students working directly with someone from faculty, and also then from industry. The fact that like I expose them from second year to the aerospace industry, that helps them to build a network early on in their career. So I think for us, the students are really enthusiastic about aircraft, but they also see the value in having that closer connection. So there's also something, at least with our large cohorts, that motivates students to enter these projects.
I mean, you can say that sometimes a little machine is just a machine, but then of course you move into rockets and stuff, and they are never just machines. So the socio-technical aspects are there. So one issue is how to offer places in the program for all types of interests and develop it as the years go. I was a little bit upset by Jeannie's, sounded almost like there was bullying in the program. And that is perhaps something that we need to take care of.
Yes, so I did another study actually with Pia, who's here, on the experiences of students who come from very challenging socioeconomic backgrounds, who enter engineering education later in life. And these students often present with clinical conditions like depression, autism, etc. And I also saw that some of the students who experienced the greatest psychological stress under these conditions were also students who suffered from dyslexia, social anxiety, etc. And what we found was that there was very little awareness at the faculty level, at the staff level, of these conditions and how they affect students. And there was also these chaps that we interviewed for this study I did with Pia. They did not know how to get support. They were reluctant to get support, and they didn't know how to get it, so it wasn't something that was easily accessible. My feeling was that, and we also, Annette and I are just finishing a paper on this as well, that this bleeds into then how students perceive PBL. And then we get strong, because we did a phenomenography with Annette on conceptions of PBL. And what we found is that when these negative interpersonal experiences dominate, then students tend to have a negative affective conception of PBL that can then have an impact on the kinds of engineering identities that develop. For instance, more competitive instead of collaborative engineering identities. But the affective reflection is not really included. So reflection in PBL learning outcomes tends to be metacognitive, as in the Kolb model, and it doesn't really include so much affective issues, neither at the student level nor at the staff level. And I think it's really important, based on the results of this research, that we start including that.
We are nearing the end of the session, and if you want, I'd like to invite everyone to write just a few words as a reflection of what you take from this session. a little takeaway message or just a greeting. Leilani, your program, it's really all respect to you who are working under quite challenging circumstances, the class size, etc. How do you assess? I have seen questions about assessment in the chat. How do you assess the students?
Yeah, so that's a really good question. I think we are also part of the vertically integrated consortium, and some of the other projects that are similar run based on how they assess. So they typically have students throughout semester have to keep a logbook that is assessed, and they do peer assessment. So the team leader, the staff member involved, would do a logbook assessment to see your process throughout the semester, and that's basically your reflections, whatever technical design you've done, etc. And then there's peer assessment. In this specific team, and in most of the others, we don't assess the overall process, but each individual project-based module has an assessment criteria of its own. So what worked really well here, and that was from the beginning when I tried to think of how to do this, I had to also think about how to make it sustainable and for myself in terms of my own time that I can contribute. This has never been seen as part of my actual workload. It's always been something on the side that I'm playing with. So I relied on the fact that I have some of my capstone research students take part in it, and I give them the major projects. But all the other students are assessed in different modules, depending on from which module they're coming in on. And then they're assessed according to their different levels and whatever is required in that PBL space. So yeah, so it depends per year group what the outcome is for that specifically, and that's how I then play a role in assigning the original task to make sure that they can reach that outcome. Yeah, so I don't know if that answers the assessment question, but I've been thinking a lot about assessment and the purpose of assessment, because a lot of people have asked, why did I assess teamwork as a whole in my specific project? But teamwork has never been an outcome, but there's a lot of value that is gained through that. So I guess that's why at the moment, while we're like unpacking and taking everything apart and trying to understand how it works, that's also something that's mulling in my head. Like, how do you actually assess a process like this effectively? Assessment, I'm always worried, drives behavior of the students. And
Yes.
The fact that teamwork hasn't been assessed has made it more organic, in my opinion. But I don't know.
Thank you so much to everyone. I think we could actually continue all day. We haven't talked so much about the interdisciplinarity nuances here, and there are so many avenues we could have gone along. But I think we shed some very interesting spotlight on these issues, and I also felt that there is a true community in the world handling similar challenges, and that at least we have each other to draw on when it's a very complex task that we are facing. So let's keep the room open a few more minutes if you want to add a farewell message in the chat with your takeaway lesson from the session. And I'd like to invite some applause again for the contributors and all commenters. Thank you so much.